Well, welcome everybody. We're really excited to have you all with us at this presentation today. This is going to be a lot of fun. I'm going to start sharing my screen here. We're going to just jump right in. I know your time is precious and valuable, so we're going to try to get through this as quickly as possible. So just a couple of housekeeping items here on this webinar, just to familiarize yourself with the platform so that you can kind of expect or know a little bit of what to expect. We're going to be doing some poll questions throughout the presentation. And so some of you, if you're watching this on full screen mode, it sometimes has a little bit, it struggles with allowing you to vote if it's in full screen. So you may need to hit the escape button when the poll comes up so that you can do that. You're all muted so we won't be able to hear any comments that you make or anything that you say. But you are allowed, we've got the questions pane there on your thing. So if you have any questions, feel free to type those in. What I like to do is go through and then answer those questions at the very end of the presentation. And so feel free to type in any questions or concerns you have, and I'll do my best to answer those at the very end. So just we do have some other people on the line with us here. I'll unmute them when we're ready to talk to them a little bit, but I'll introduce you to them in a few minutes. But we're going to go ahead and just get started. Today is our first presentation, our first monthly webinar for the Mountain States Concrete Pipe Academy. So I want to thank everybody for joining us. This is being recorded, so if there's any part of this that you want to go back and watch later, it is being recorded, and then we will make the link available on our website to go back and view it at any time. And if there's people in your office who didn't get a chance that you think would benefit from this, feel free to invite them in the future to any future webinars, or to view this after the fact. They can always do that as well. So we're going to go ahead and jump right into it today. The topic is concrete pipe fundamentals. We're going to be going very basic today on concrete pipe and talking to you a little bit about that. I am your presenter today. Jason Allen is my name. Concrete pipe is my game. So just a little bit about me. I graduated from the University of Utah in civil engineering. I got both my bachelor's and master's degrees. I was attending school there at the time that Urban Meyer was coach. So that was kind of a fun time to be attending the University of Utah. I have about 19 years of engineering experience. I started out at a small company here in Ogden and doing surveying work. Fell in love with engineering, returned from a mission, and decided I didn't want to be a doctor. I was too smart, didn't want to waste my life being a doctor. I was way smarter than that, so I decided to go into engineering. And my first couple of jobs dealt with land development. I transitioned to the public sector and was the Morgan County engineer for a little while. After that, I actually was a high school math teacher for a year, and then I got back into consulting and did mostly drainage projects for large municipal and state roadway projects. So that was a lot of fun. I have owned my own company, and now I do marketing engineering. It's a lot of fun for the Concrete Pipe Association. So I am here representing the Mountain States Concrete Pipe Association, and I get this question a lot. A lot of people say, what is the Mountain States Concrete Pipe Association? What do you do? They ask, so do you work for this company? Do you work for that company? What is it that you do? And I thought it would be good where we're talking concrete pipe fundamentals, and we're kind of introducing hopefully a new audience to the association and to concrete pipe here. Why not take a few moments and share with you a little bit about what the association is and what we do. So who we are. First of all, we have two main member companies that are our producers here in Utah and Idaho. That's kind of our area that we cover is Utah and Idaho. We have Geneva Pipe and Precast, that is a Northwest pipe company, and they have plants in Salt Lake, Orem, and the St. George area. So they've got 3 plants here in Utah. And then also we have Old Castle Infrastructure, who has 3 plants, one in Ogden, one in Idaho Falls, and one up in the Boise area. So we've got 6 different manufacturing plants between the 2 companies, and we're very grateful for all that they do to make a lot of these activities and things that we do for the association possible. So they're awesome and very supportive. We also have two other member companies that we want to recognize that sit on our board of directors, and that is Ashgrove and Wholesome, who are our cement suppliers. And they give us a lot of great feedback and help us kind of dial in with other concrete associations and different things, and give us suggestions on how we can improve our processes as well. They're a great help and good support for us. We do have, as I mentioned before, we have a few other people that will be joining us throughout this presentation, and I wanted to introduce you to them, but unfortunately I just got a text that two of them are in another meeting that's going a little bit long, so they may not be on for a moment. So I get to give you fun facts about each of them, and they're not here to defend themselves, so that's even more fun when I get to share fun facts and they're not around to defend themselves. So first of all, with us today, that will be joining us in a few moments, is Heather Christensen. Heather is the marketing engineer for Geneva Pipe and Precast. And Heather, fun fact about Heather is she was recently married, and she married a gentleman who attended high school at the school that I taught at when I was a high school math teacher about 12 years ago is when I was teaching over there. So Heather's just a young one. She's kind of the youngest of our group here that we work with, but she brings a lot of great insight and ideas and kind of that young perspective and energy to the group. So we're thankful to have Heather part of our association and the help that she gives us. But also will be joining us when they get done with their meeting is Mike Blackham. Mike formerly used to work for Oldcastle Infrastructure, left and went into consulting, where he was doing consulting for pipe manufacturers, and now he was hired about a year and a half ago by Geneva Pipe, and so he is working also with Geneva Pipe. He is their design engineer and technical engineer for Geneva Pipe. He still lives up in Boise, so he's working out of his home office up in Boise, but he comes down to the Orem office a couple times a month. But fun fact about Mike is that his brother is a professional baseball pitcher, and he is a pitcher for the Oakland Athletics organization, was traded last year from the Mets, where he was pitching for the Mets organization, and was traded to the Oakland A's. And so we're hoping that now that he's on the West Coast, Mike and I have talked about going out and watching him play a little bit more now that he's on the West Coast, where he was it's a little bit tougher to get out to New York to watch him play. So we're excited about that. And lastly, with us, and we do have him with us on the line today, is Jeff Peck with Oldcastle Infrastructure. Jeff Peck is the closest human embodiment of the fictional character Ron Swanson from Parks and Recreation. Jeff does not like to be on the grid, just like Ron, and so as such, it was a little bit tougher to stalk him and find a picture of him. So I just decided to show a picture of Ron Swanson because that's kind of what Jeff reminds me of. Fun fact about Jeff is the one that got me into guns. And so before I met Jeff, I owned 0 guns. And then when I started working for the association 5 years ago, about a year in, he got me into shooting, and we would go shoot shotguns and different guns and things. And I had so much fun doing that Jeff got me into purchasing firearms. So I now, in the last 4 years, I have gone from 0 guns to now I own 10 guns. So that's pretty exciting. I used to joke around and tell people that I was a Utah Democrat, and they would say, "What does that mean?" And I said, "I have less than 10 guns." And now that I have 10, I guess that might make me a Republican now. I guess I don't know. I'll have to see. So just got a text from Jeff that his control seized up, and he doesn't have any microphone control, so he can't defend himself either. But we do want to welcome Heather with us. Thank you, Heather, for joining us. I was just giving some fun facts about the group, and you weren't here to defend yourself. So
oh man, I see you have my wedding photo up.
Yes, indeed. The fun fact was that you married a gentleman that was attending school when I was a teacher at that same school 12 years ago. So that's the fun fact about you.
It's ironic. Small world. And Jeff's photo, that's looking dapper.
Yeah, Ron Swanson. Jeff is living off the grid, so it's hard to find pictures of him. He's off the grid there. And again, Jeff can't defend himself, so good luck with that, Jeff. If you have any comments, feel free to text them in to me, I guess. So what we do, let's talk a little bit about what the association does here. Our primary goal is to provide technical assistance for the RCP, reinforced concrete pipe, and precast concrete industry. And in doing this, we work closely with engineers and specifiers, inspectors, and installers, whether they're independent contractors that are doing work, or if you have at your own city installers that are doing the work, we like to work closely with them to ensure that our products are being not only designed, but specified and installed and inspected correctly. We want to make sure that our products are going in the ground correctly. That's our number one goal. And how we do it is we give a lot of presentations, as is obvious by you being here today. And we typically will present at conferences. We've now, because of the COVID virus and the quarantines and the shutdowns and all that, we've employed more webinars, which have been very successful and very well received. And what we like about those is we get to record those and you can watch them at any time. So it's very helpful if you see something that you want to watch again. That's what's good about the webinars. But we also have done lunch and learns. We hope that by the middle to end of this year, we're going to be back into to folks' offices and be able to go and do some lunch and learns with folks and bring lunches in and answer your questions with you there. We also review and write specifications with people. So if you have any specifications on or projects that you're working on that you're unsure how your specifications measure up and you want us to review those and take a look, we are more than happy to do that. We have a lot of experience in reading and writing specifications. Heather, Jeff, Mike, myself, we all sit on national specification committees that work with ASTM, AASHTO, different national specs for concrete pipe. And so we have a lot of experience. We have a lot of contacts across the country with specifications, and we are more than happy to help you make sure that your specs are as good as they can be. We also answer a lot of constructability or design questions. So if you have any questions, I'll talk about that a little bit later in this presentation on some of the questions that I've received and how we can help with that. So it's a really fun job. I really enjoy what I do. I know Heather and Jeff and Mike, they really enjoy working with people and helping, making sure that our products are being spec'd correctly. So it's a lot of fun. If you have any questions, feel free to reach out either by email or phone. We're more than happy to help you out there. So now we've got some new things that we're implementing this year. If you've watched any of our video newsletters from the last couple of months, you've probably seen some of the new things that we are implementing. First of all, this is, as I mentioned before, our first webinar as part of our Mountain States Concrete Pipe Academy. This is a cool new program that we've implemented this year. I just put the web address at the bottom of the screen if you want to write that down, or you can go and visit that. It's mountainstates.concretepipe.org/academy, or you can just go to the Mountain States website and click on the Academy tab and it'll take you to the screen. But we are providing presentations once a month from the members of our association. So you don't have to hear me every single month giving a presentation. We've got folks from Wholesome and Oldcastle and Geneva and Ashgrove that are going to provide some of their insights. We've got different topics. It's not just always going to be about concrete pipe. We've got installation, we've got box culvert, we've got concrete mix design, we've got cement manufacturing, we've got sustainability, a lot of different cool presentations that we're really excited to share with you this year. If you go to the website, this is what it looks like. You can click to register for all the various webinars we've got coming up. Once this webinar is over today, I'm going to make it available to register and watch at any time. It'll be on this same page, but instead of being an upcoming webinar, we'll put it under the past webinars that you can still view. So anybody can get on and view this at any time for the whole year. So if you want to go and watch it later, you're more than welcome to. If you miss one of the webinars, you can watch it at any time between now and the end of the year. With our academy, we have implemented the Pipe It program. This is a play on the old Book It program that we had when I was a kid, where we would bribe young children into reading more books. And so everybody got a button and you would get a star, a gold star every time you read a book. Well, we're going to do it a little bit different. We're going to give you a gold star every time you attend a webinar. So when you attend a webinar, you'll get a gold star, and you get 10 gold stars, you get a prize. So basically that's how it works out. You attend your 10 Mountain States Concrete Pipe Academy webinars in any time in 2021. So if you miss them in the first part of the year, feel free to watch them at the end. That's fine. We'll send you stickers when you watch webinars. You can put all 10 stickers on your button. Once you've got it filled, you send us a picture wearing your button proudly. And you get to win prizes. Everybody who attends 10 webinars will get a cool prize. This is one of the prizes here. You get to choose between one of these 2 shirt designs. The Trust Me, I'm an Engineer, or I sat through 10 hours of technical presentations and all I got was this lousy shirt. You'll get to choose which shirt you want at the end of the year if you've attended all 10, and we'll get a shirt out to you that you can represent the Mountain States Concrete Pipe Academy proudly, that you're a graduate of the Academy. Also, we're going to be entering you anytime you attend a webinar. We're going to enter you in for a drawing for gift cards and other prizes. And for those that attend 10 out of the 12 webinars for the year, you'll be entered in for the grand prize, which is a trip with us to go to Topgolf and have lunch and play a little golf with us. So that's going to be a lot of fun. So we're looking forward to this program. It's going to be a lot of fun. Another cool thing that we're doing this year is we are doing monthly project profiles. So we are going to be putting in a profile every month. And when you go to mountainstates.concretepipe.org/project-profiles, or just go to our main page and click on the project profiles tab, you'll come up with this page, and we are going to highlight each project every month. Now, when you click on the full project profile, we've got a couple of pages worth of pictures and videos and information about this project. And the idea is we're hoping that we can give you, as design engineers and designers, a little bit of inspiration for maybe upcoming projects. And if you've got an issue that you're thinking about on a project, we're hoping that these different project profiles will give you that little bit of inspiration to say, what can I do a little bit differently? Maybe I can implement one of these unique design situations or unique designs that these manufacturers and contractors did on a different project, so that we can help you be the best designers you can be. So for January, as you can see here, our project profile for January is the Baker Canyon Wildlife Underpass under I-15 between milepost 135 and 142. And so this is a really cool project where it was a clamshell design, and by that we mean they placed 2 3-sided boxes on top of one another because it was just so big. The key with these wildlife underpasses is you want them to be big enough that the wildlife will actually use them. If they're too small, the wildlife they don't really use them that much. So it has to be really, really big. So these were 2 3-sided boxes that were 24 feet wide by 6 feet tall. So it ended up being 24 by 12 feet. And it was about 160 feet worth of these boxes that were put in to get the wildlife from one side of the freeway to the other. It's a safety concern for obviously for motorists traveling on I-15 that we want to keep as much wildlife off the road as possible. So this is one solution that we've come up with to help with that. The designer on this project was Avenue Consultants. The contractor was W.W. Clyde, and the owner for this project was UDOT and the Division of Wildlife Resources. Geneva Pipe and Precast provided the boxes. And so next month in February, we'll be highlighting a project from that Oldcastle Infrastructure did. So look back for that. Heather, you did this project. Anything you want to add about this project?
Yeah, so one thing is Harward and Reese was actually the subcontractor that works directly with the box culvert. So they ordered the boxes from us. They installed the boxes. W.W. Clyde was the general or the prime contractor. And the cool thing about this is that it's been in collaboration with Utah Department of Transportation and the Division of Wildlife Resources. And so Utah basically went down in history. From when I started researching about this project, it was pretty cool, how things have changed just over the last couple of decades. I think it was the late 1970s is when Utah kind of hit the big show in national news for construction like this, because we did our first wildlife overpass back then. And since then, UDOT and Division of Wildlife Resources has collaborated and installed about nearly 60, I think it's like 55 or 56 at this point, underpasses and overpasses, with the majority of them being culverts. So that's pretty cool. I mean, we're kind of one of the leaders in the nation here in Utah with projects like this to improve the safety of the roadways.
That is cool. Yeah, Utah's surprising. I think a lot of people, when I talk nationally, when I go meet with some of our national people, they're a little bit surprised at how cutting edge Utah is when it comes to design and solutions in the precast world. We have some great engineers in this state that have some unique problems and situations that and we come up with these interesting solutions, and folks are a little bit surprised that little Utah is coming up with such cutting edge and interesting advancements that help, you know, the country all over. So we'll get into some of those a little bit later in the year when we talk about box culverts and some of the things that we've done in the Utah market that blew the socks off of people when I went and presented it nationally on how much easier it is that the way that we install box culverts here in Utah versus how other people were doing them across the country. So we're excited to share some of those with you throughout the year. But anyways, yeah, thank you, Heather, for that information. This has been a great project. It's been recognized across the state. And one thing that we're going to be doing with these project profiles is each month we will be highlighting a new project. So you can look at our website and we'll put it on social media and share it with everybody. But you know, the box culvert, or what we want these to do, the criteria is if it's either reinforced concrete pipe, box culvert, or any unique precast situation that we think would be beneficial for you engineers and designers to look at. And then at the end of the year, we're going to select from the 12 that are posted on our website and that we select throughout the year. We're going to select one of those to win a Project Achievement Award from Mountain States Concrete Pipe Association. So we'll be presenting the design engineer, the contractor, and the owner of the project with a plaque and a framed picture that talks about the project, and award them the Project Achievement Award, and hopefully pass those along each year to our national association that does a Project Achievement Award every year as well. So if you have a project that you've worked on that meets any of those criteria, either a box culvert, an RCP, or any unique precast project that you think would qualify, send that our way. We would love to see what suggestions you have on including a project in this project profile. We'd be more than happy to take a look at those and try to select one to help get some notoriety for you and your project and your company. So keep that in mind. If you want to do that, feel free to just email us and let us know that you would want your project to be considered for that.
Yeah, and okay. One more comment on that, Jason, is if for American Concrete Pipe Association, they do their National Project Achievement Award. So that's basically everywhere in the States, but they have a different criteria than what we're working with. We want to recognize all projects precast, even no matter who the owner is, but national, it has to be a DOT project. So we'll have to select the ones from the DOT projects that we look at through the whole year and see which ones we can send off to national. And then what happens is if they get selected as the American Concrete Pipe Association Project Achievement Award, ACPA actually presents them that award at the annual AASHTO conference, if I'm not mistaken. And so that's pretty cool because then that's recognizing the state. So we're looking for a lot of DOT projects, but ultimately the Mountain States Project Achievement Award doesn't have to be confined to just DOT projects. If you've got a really cool job that's, you know, not with UDOT, certainly we still want to consider it. Certainly we still want to put it in as the nomination.
Perfect. I love it. Yeah, no, that's a great point there. So that we'll be selecting to pass on to the DOT projects, but to win our Project Achievement Award, it can be any project that was done throughout the year. So whether it's a private or you know, a city, county, or state job, we'll be selecting from there. Great point, Heather. Thank you so much for that. All right, some takeaways here. The three big things we're going to be talking about today, and we're going to zip through them pretty quickly, we're going to talk about some basics of reinforced concrete pipe. We're going to discuss briefly some manufacturing and testing criteria, and also a little bit into design. And we're going to go ahead and get started first with a poll here. So I'm going to launch our first poll question here. Give me just a second there. All righty. I just want to know, just roughly here, remember to escape out if you're in full screen mode so that you can vote. But I'm going to go ahead and launch this here. I'm just curious what percentage of projects are you specifying RCP? You know, I'm curious on who's specifying how much. Is it, you know, 0 to 20%, 20 to 40, 40 to 60, 60 to 80? I'm just curious to see those of you that are on here, how much RCP we're speccing out. I'll give you just about another 30 seconds or so to vote. About 2/3 of you have already voted. So, and then I'll post the results here and we'll show you. So don't be shy. Feel free to jump in there and vote and get used to it so that we can, when we have other poll questions later, you know how to do it here. And So we'll give you about another 10 seconds or so to vote. About 80% of you have voted. All right, we'll give you about 5 seconds. And okay, I'm going to close it here. And I'm going to share the results with us here. Okay, so it looks like about 8% said 0 to 20%. 19% of you said between 20 and 40%. Almost 30% said between 40 and 60. So about half of your projects are being spec RCP. About a quarter of you, 22%, said between 60 and 80, and 80 and 100. So that's interesting. Well, thank you. I appreciate you sharing that. We just we're curious to know that, and I'm going to hide that and get back to our presentation here. So. All right, perfect. Well, let's go ahead and talk a little bit about concrete pipe here, and what the basic 2 critical functions are for concrete pipe. So, buried pipe must perform 2 critical functions. Heather or Jeff, either of you want to jump in and take a stab at what those 2 critical functions are?
Jeff, if you want to jump in, go ahead.
Well, one of them certainly is structure.
Certainly structure, of course. And the second? Heather, you want to take that one?
It's obviously got to be a conduit, so it's got to
absolutely
fluid.
Absolutely, conduit and structure. When most of what we do is mostly drainage pipe, so the conduit is typically to transmit the water, whether it's mostly gravity, obviously with sewer or storm sewer, and but yeah, conduit and structure. Now, concrete pipe is we call that a rigid structure, a rigid pipe, and that is a structure that is bedded with soil. That's a little bit different from some of the flexible pipes. So we're not going to talk about those today. We're just going to focus solely on concrete pipe, but it is it's a structure itself. So when you get concrete pipe delivered to your job site, we are delivering an actual structure to the job site. You are getting that, and then it is bedded with soil. And so we'll talk a little bit about the specifications for the installation and the manufacturing of that, but we are building and delivering an actual structure to the job site. Now, when you look at what percentage of the structural system is handled by the pipe itself, depending on the class that we're using, depending on the type of bedding, depending on the foundation and the backfill, you could see anywhere from 70 to 90% of that system strength coming from the pipe wall itself. So that pipe is responsible for transmitting a lot of that load and carrying that load. It's really remarkable on how much that pipe has to handle, right? And so it's very important that we're taking great care when we manufacture it to ensure that it meets those design criteria, that it meets the loading criteria, that it's transported efficiently and safely, so that we're not we're not damaging the pipe as it gets there, because that structure is so important. As I mentioned before, depending on the class, the foundation and the bedding could account from anywhere from 10%, as little as 10%, up to 30% of the system strength. And so that's opposite. That's about opposite with like a flexible system, that you see more of it is the 10%, 5 to 10% on the pipe itself, and 90 to 95% of the bedding and foundation. And so you've got to really be careful with that. Making sure that we're designing and installing these products correctly. And so a couple of other things with concrete design that we want to keep in mind is that your design life for a concrete pipe is typically 100 years, even though we have plenty of work or plenty of projects that are in the ground that are so much older than that. And I'll talk a little bit about some of those here in a moment. But from a hydraulic standpoint, we're not going to get too much into hydraulics today, but a Manning's N that is recommended by our plants is a 0.012. We'll see different values. I've seen engineers use 0.011. That's okay. 0.013 is pretty common, but we recommend 0.012. Even though in some of our lab tests, we've been able to get some of these concrete pipes down as low as 0.009, 0.010. The recommendation is to use a Manning's N of 0.012. As far as structure, we have, as I mentioned before, each of our plants have structural engineers. Mike Blackham, that I introduced you to earlier, he's one of them. That's the engineer for Geneva Pipe. Troy Banks is the engineer for Oldcastle, and they are certifying and stamping these designs. And so the plant itself assumes the liability for that structure. Now we're also assuming that the contractor is handling it correctly, installing it correctly, that it was designed correctly. But as far as the standard classes and meeting those criteria, our structural engineer are the ones that assume that liability, and they are stamping those designs to say, yes, this pipe was manufactured correctly and it will meet these loads. This is a pipe that I'm really fascinated by. This was installed in 1842 in Mohawk, New York, and it was upsized. This was an old sewer line that they upsized in 1986. So it was in the ground for almost 145 years, 144 years old when they removed it. It's interesting because when you go to Dallas, Texas, if you go to the American Concrete Pipe Association's office, they have a section of this pipe in their office so that you can go and look at it. Structurally, this pipe was still fine. It still met all the structural requirements that it needed to after 144 years in the ground. The only issue was it was too small. They had some growth and needed some additional capacity in that line, so they upsized it after 144 years. And so structurally, it was still very sound. And so these pipes, they can last. We mentioned 100-year design life, but some of these pipes will last even longer than that. This is an interesting project that's more local. That one in New York, that was an old pipe. This is one in City Creek down in downtown Salt Lake. Back in 1908, there was some major flooding in City Creek, and so they decided to pipe a large portion of that. And so they put in a 7-foot diameter pipe from 400 west to 900 west. This was back in 1909. They bid this out. It was an 8-inch thick reinforced concrete pipe, and they did it all cast in place at the time. So you could see those like little mining carts that they used with a rail system to take the material to and from the forms that they had set up. It's really a fascinating project. And for any of you that were wondering, for that 4,000 feet of 7-foot diameter pipe back in 1909, the low bid was Davis and Huser, and they bid it for $48,252 was the low bid for 4,000 feet of 7-foot diameter pipe, 8 inches thick, reinforced. So kind of a cool little project there. Here's some more pictures of it. There's, you can see the forms that they've set and the steel that they've got in there. And this is that same location there that's completed after they stripped the forms. And this is what it looks like today. A large portion of that pipe is still in service today, and it's still functioning fine after over 110 years. It's still in service and still functioning. Kind of a fascinating thing there. So one of the things that we provide that the American Concrete Pipe Association has that is something that you as engineers can use. This is a cool little app that they've developed and put out there that's a free download that you just can look for the Compare Flow app in the App Store, whether you're using Apple or Android products. But it's a cool little app that you could download to your phone, and you can compare flows of different products and different materials. And so if you want to do just a quick calculation to see what size of pipe you're going to need, whether you want to use concrete pipe or plastic or corrugated metal, or whether you need to see what if I can't do a round, what if I need to do a box culvert, you can compare flows of different things. So this is what the app looks like when you download it. It's just that little orange app in the top left-hand corner there. When you open it, it's called the hydraulic capacity of culverts. You go to the flow capacities, and this screen opens up there, and you can choose between circular concrete pipe. We get a lot of questions about elliptical pipe. What's the flow difference? What's the change? So you can look at elliptical or arch. We don't make a whole lot of arch in this market, but usually we get most of our questions comparing between circular, elliptical, or box culvert. You can also enter in flexible pipe and see how a corrugated pipe, what the difference in flow capacity would be if you're from those corrugations versus a smooth lined pipe. It's kind of cool, but this is the output that you punch it all in there. This is for a 24-inch pipe with a roughness coefficient of 0.012, and it gives you your flows down there at the bottom. So it's kind of a cool little app that you can use and compare those. You can choose different different materials. So whether you want to look at a profile walled PVC or a solid wall or SRHDP, corrugated metal, it changes the Manning's N and shows you the difference between different pipe flows. And so you can look and see that if you're comparing a concrete pipe versus a corrugated metal pipe, there's a difference in flow where one can handle almost 35 cubic feet per second, the other one's only 23 cubic feet per second. So it's a pretty big change when you start thinking about the corrugations and different pipe materials and different things. So that's a free app that you can download. It's kind of cool to have just on your phone if you're out in the field and you need to do a quick calculation and see what flows are. Feel free to download that. It's kind of a cool little thing there. Heather, go ahead.
One other thing is if you're interested in using this app, or maybe you want a little bit more information, I know ACPA, American Concrete Pipe Association, did a webinar back in 2020, and I believe they threw it on YouTube. So Corey Frazier, I think up in Washington State Concrete Pipe Association, and then Trig also put together a presentation on this. They did a really good job. They went a little bit more in depth. So while we can't go that in depth in this presentation, if you're looking for more information, shoot Jason an email. He can send you that link to that webinar too.
Excellent. Thank you for that. Do you know, Heather, if that presentation, they also went into Pipe Pack?
I believe they did. Yeah, I think they went into Pipe Pack.
I know they did one on Pipe Pack as well. And we'll be talking a little bit about Pipe Pack today, but I was going to suggest I know there was a presentation on pipe. I just didn't know if it was the same one. If it's the same one, we'll kill two birds with one stone. That'll be great. So excellent. Great suggestion there, Heather. I appreciate that. So let's talk a little bit about specifications. I know all you engineers out there, boy, this just gets you really, amped up and excited about talking specifications. There's three main specs for reinforced concrete pipe. The ASTM C76 is manufacturing spec. As I mentioned before, Heather, myself, Mike Blackham, I know, I believe Jeff Peck, a couple of others from Old Castle. We have people that sit on these ASTM. It's called C13 is the committee that writes all these specifications and approves them. And so we sit on there and we have discussions with other engineers about these specifications. But you've got C76, which is manufacturing, C497, which is your testing spec, and C1479, which is installation. We're going to focus mainly on C76 today and a little bit of C497. 1479, when we talk about the installation of concrete pipe webinar that we'll be doing in a few months, we'll be focusing almost exclusively on 1479. And so we'll talk a little bit more about that later, but we're not going to focus on that one today. But when you have, actually, you know what? Let's go ahead and do our second poll right now. Let's see what we got here. I'm going to pull up the second poll. And the question is, how many standard classes of circular RCP are there? These are standard classes. This is not like special design. These are standard classes. How many standard classes?
I know this one.
3,
I wish
4,
I could
5, 6. What was that, Heather?
I wish as a panelist I could answer this one. I know it.
Yeah,
Heather knows it. We got a little bit of flack last time when someone said, no, there's this many because you've also got special design. So I had to put in standard classes this time. I almost just said the answer. There's a number of standard classes of pipe, and this is not what's available locally, but because that's a little bit different than what the standard classes are. So I'm going to give you about 10 more seconds here to vote, and then I'll share these. There, Jeff, did you have a comment? I saw
No,
Jeff.
I was just, I felt like Heather. I know the answer, so I want
you know the answer
for the prize.
This
Boy,
one's
it's amazing, Jeff. If you're in this industry for 20-something years, you can answer a basic question about basic RCP. Imagine that.
One answer.
Don't be ashamed if you don't know the answer, because just because we're doing this every day of our lives, I mean, it doesn't mean that everyone is. So
exactly.
So don't be ashamed if you pick the wrong one.
Results. 19% said 3, 19% said 4, 59% said 5, and 3% said 6. So, Heather, I'm gonna let you do this one since you were so excited first, and then I'm gonna let Jeff try to answer the third poll question. But Heather, what is the correct answer on the number of standard classes of RCP?
So as the third option, it's 5 classes of strength. The lowest class is class 1, the highest class is class 5. Class 5 is going to coordinate to your strongest class. In class 1, you really don't see a lot except for maybe irrigation purposes. In fact, Geneva, we don't even manufacture class 1 or 2. that's a hint for you. If you find that your job requires a class 1 or a class 2, great, specify it. We'll give you the class 3 for the same price. But just because man hours and stuff about the reinforcement, it's just, it doesn't end up working out for us in the end. So we do class 3, 4, and 5, but there are 5 classes total.
Yeah, the reinforcing is really where you get your changes between classes, where a class 5 is going to have the most reinforcement and a class 1 is going to have the least. And when you start talking about a class 1 to 2 to 3 to get those strengths, it's such a minimal amount of steel to increase that to keep it to keep a certain steel diameter on site is almost, it's almost not even cost effective to store it and keep it there when you could just do a class 3, you know. So it's so that's one of the reasons. It's just the economics. It's actually cheaper to stockpile class 3 than it is to manufacture class 1 and 2 at larger diameters. And as Heather mentioned, for irrigation projects that don't have nearly as much load, or larger diameters or things like that, you might see some pretty significant cost savings through a class 2, but that's for the manufacturers. They decide what's going to be the best, most cost-effective option for you. But you know, I recommend that you talk to the manufacturers as much as possible on these projects and have them, you know, talk to them about it and see what you think. So great job. Thank you for sharing that. Let's move on now to why there's 5 classes and what that means. So I want to talk a little bit about what exactly that means. So when we have a pipe that is loaded on top and bottom, which is basically what we do when we put a pipe in the ground, we're loading it on the top and on the bottom. You're going to have 4 different tension zones. And if you look at the figure on the left, the tension zones are denoted by the black areas there. So those dark areas are the tension zones. So we want to make sure that we have steel in those tension zones to ensure that we're not cracking the pipe. We know that concrete is going to crack if it's loaded. So we want to put steel in there to either minimize the cracking or eliminate it altogether. You see on there, because the tension zones on the inside of the pipe, you've got the flow line, which is the bottom, and the crown, which is the top. You're going to see the cracks manifest on the inside of the pipe there, but where the tension zones at the spring line, which is that midpoint across that middle line, if you were to cut the pipe in half horizontally, it would be that horizontal line right in the middle of the pipe. That is called the spring line of the pipe. And you see the cracks happen on the outside of the pipe because those tension zones are on the outside. And so this is a table. I know you guys love tables. This is right out of C76. This is for a class 3 pipe. And what you're going to notice is you've got your deloads, and we're going to talk a little bit about what that deload means. And we've got 2 different scenarios for deload. One, to produce a 0.01 inch crack or a 100th inch crack. And then that 1350 is the load, the number of pounds that you need for that. And I'll get into what all that means in a minute. And then you've got ultimate load. And ultimate load is once that pipe fails, you load it up to failure point. We want to know at what point is it failing, right? So when you go through this table on the left-hand side, you've got the pipe diameter. This is the inside diameter of the pipe. You've also got your different wall thicknesses, wall A, wall B, and wall C. Wall B is the most common that we use in our market here. You see a lot of B wall there, and B wall is cool. Those are the forms that we're using, and the B wall is nice because it has a real easy way to calculate your wall thickness. But as designers, we need to keep this in mind, what our wall thickness is, to make sure that we're calculating the correct cover and the correct cover requirements. So what the simple calculation for wall thickness on a B wall is you take the diameter in feet and you add 1 inch to it. So if for a 24-inch pipe, that's 2 feet in diameter, and then you add 1, so it's 3 inches is the wall thickness. So if you had a 36-inch pipe, that would be 3 plus 1 inch is 4 inches thick for a 36-inch pipe. If you have a 30-inch pipe, notice on the 30, I didn't highlight that, but 30 is 2.5. You add 1 inch, it would be 3.5 inches. So it's actually really easy to calculate that. For strength classes, these are, as Heather mentioned, there are 5 strength classes. Class 1 is going to be 0 to 800, and that is pounds per foot of diameter per foot of lay length of pipe. That's what we're calculating. So pound per foot is not pounds per foot squared. It is pounds per foot of diameter per foot of lay length of the pipe. Class 2 is anywhere from 800 to 1,000 pounds. And this is for your 100th inch crack. This is the one that to produce that crack. Class Class 3, as I said, is 1,000 to 1,350. Class 4 is 1,350 to 2,000. Class 5 is 2,000 to 3,000 pounds, and and anything above that would be your direct design. So anything that's over 3,000 pounds per foot, we would do a special design for that, and that's why we have structural engineers on staff. Now, people always ask, well, what about that 100th inch crack? Tell me about that. So we do a 3-edge bearing test, and I'll show you some pictures of what that means. And it determines the strength of the pipe for 2 different criteria. Number 1, to the load to produce a crack with a width of 1/100th of an inch. So we have a little leaf gauge that we determine how much we're loading to create that 100th of an inch crack. And then the ultimate load is that failure load. So once you take a pipe to ultimate load and you crush it and it has an ultimate failure, that pipe cannot be used anymore. That is a failed pipe. We throw that one out. And we have so many that we have to do per spec, how many of those we have to do. But the 100th inch crack is an interesting phenomenon, because on small cracks, we call these hairline cracks, there's a phenomenon in RCP known as autogenous healing. Now, when I was first told about this, I thought this was black magic, and I thought it was fake, and I thought Randy was just messing with me when he told me this. But this is a real phenomenon, and we actually did an experiment to show this. It's on YouTube. If you look up autogenous healing, you can see the experiment that Mountain States did a couple of years ago. And what we did was we cracked a pipe. We took it to, we had it was about a 5/100th of an inch crack. So it was a little bit more, about 5 times. That's about the width of a dime, is 5/100ths of an inch. And we cracked the pipe all the way through. And then we sealed the bottom with concrete, and we filled it up with water for about 3 months and allowed it to heal itself. Within a week, the cracks had almost completely sealed up where it wasn't leaking anymore. We kept water in it the whole time. We stood it up on its end and kept water in it and just put a hose in there and let water run through it. And at first it was leaking very bad, and then within about a week it sealed itself completely up. Within 3 months it had healed all the way through the pipe. It wasn't leaking anymore, and you start seeing this white effervescence in there. And what it's doing is you've got the calcium hydroxide in the cement mixture that mixes with the oxygen and the water and the carbon that's in there, and it creates this calcium carbonate, or this limestone, that seals the crack and actually becomes stronger than the concrete itself. Limestone is actually stronger than the concrete mix. And what we did was we retested it. We put it back on the 3-edge bearing test and reloaded that pipe, and it ended up having 23% more strength than when we originally cracked it. And so, and it cracked in a different location. So it created it was actually stronger in that spot. And so it cracked at a different spot, but it actually made the pipe stronger to just sit and heal itself for 3 months. It was kind of a fascinating experiment. As I mentioned before, this is the 3-edge bearing test, or the deload machine. I'll show you some real life pictures. On the left is back when Jeff Peck first started in this industry. This is how they were doing it. Notice they used to wear those fedoras and suits and ties, and they just throw bags of cement on top of it. You know, that was 100+ years ago when Jeff first started in this industry. On the right is an actual deload machine, where it's a hydraulic press that they load. This is what it looks like. We typically, if you notice, they call it a 3-edge bearing test because there's 3 points of contact on this pipe. If you notice the 2 and 3 down at the bottom, they space those out, and they want to space it because you don't want the pipe to roll on you. That could be a big safety hazard. If it's only 1 point, then it could roll on you, but you're trying to duplicate a point load as much as possible. So at the top you've got 1, and then at the bottom you've got your 2 and 3 loads. So those are your 3 edges that are supporting that pipe. On the top, we usually have a rigid steel beam with a wood beam underneath it, and that wood beam takes away some of the shock there, and then they'll sometimes put a rubber strip on there as well underneath the beam. And what that does is you don't want the metal beam or that steel beam in direct contact with the concrete, because that can be really harsh, that connection point on there. So you want to put something in there to kind of brace it, either rubber or wood. It'll compress a little bit, but then after it reaches compression, it's going to get you that load number real easy without damaging the outer part of the concrete and causing unnecessary cracking too early. If you notice down at the bottom, there's a requirement for, depending on the diameter of pipe, is how close you want those rubber strips. So for every foot of diameter pipe, you put it 1 inch. So if it's a 24-inch pipe, they're 2 inches apart. If it's a 48-inch pipe, they're 4 inches apart. I had someone telling me, man, we're getting such high deload numbers. We don't know why they're so high. They're about double what they should be. And I noticed that they were running, I noticed that they were running a 48-inch pipe, and then they didn't move the beams in for the 24-inch. So it was, those strips were too far out, and so we made the adjustment, and then they started getting the numbers they were expecting. They weren't as high as they thought. They thought, man, what's going on with our mix design? Why is it so high? But it just turns out they just didn't move those strips in. So we fixed it and ran the pipe again and got the numbers that we were expecting. So that's, you gotta watch out for that. That's a big one to keep out there. Keep in mind. So these are the rubber strips that you can see. They're a little bit rounded, so the pipe is cradled there. This is what it looks like. If you come to any of our plant tours, you can see this in action. We'll crack a pipe in our plant tours. We'll be doing those hopefully again this fall, in-person plant tours. But we've got some cool videos on our Facebook of this. We've got some pictures, but we would love to do this in person for you. If you want to see it done, we'd be happy to do it. So the calculations are relatively simple for a deload. You take your ASTM C76 Class 3 design. So this is, it gives us on this sheet here that I mentioned, this table, you've got this is where you find your pounds. This is 1350 and 2000, which corresponds to what I showed you on this screen here. So what you're looking to do, this is the calculation, very simple for a 24-inch diameter Class 3 pipe, right? We're gonna say for our 100th of an inch load, we'll go 1350 times 8 feet. These pipes are 8-foot segments times 2 feet of diameter. We come up 21,600 pounds. So if we can load that pipe to 21,600 pounds and we don't see a crack, we know it meets the Class 3 requirement. And so then we take it off the machine and we say, all right, that batch is good. We're going to test another one with the next batch. For ultimate load, we do the same calculation, 2,000 pounds times 8 feet times 2-foot diameter. So for a Class 3 24-inch diameter pipe, 32,000 pounds is the ultimate load. So if you load it to 32,000 pounds and it hasn't failed yet, and we get up to 32,000 pounds, we know it meets ultimate load. So that pipe there would now meet, we check it for the 100th of an inch crack and the ultimate load, and we know it meets our Class 3 requirements. So let's do a quick poll before we talk about what you show on the plans. We're going to do our last poll here. All right, I'm going to launch it here. We'll go real quick because we've only got about 10 more minutes here together. So how many standard classes of elliptical RC pipe are there? So your answers are 3, 4, 5, or 6. How many classes of elliptical pipe are there? Okay, I'm going to give you about 15 more seconds. All right, 5 more seconds. 3, 2, 1, get your votes in. All right, I'm going to share that with us here. Here we go. So 41% said 3 classes, 4% or 29% said 4, 27% said 5, and 3% said 6. Jeff, do you want to give it a stab?
There are 5 classes.
There are actually of elliptical?
I'm sorry, I got on a phone call, so I'm out in left field here, Jason. I apologize.
Sorry. Standard classes of elliptical. Congratulations, those of you that said 3, you are wrong. It is not 3. For those of you that said 5, congratulations, you are also wrong. So for elliptical class, there are 4 standard classes of elliptical pipe. There is no Class 5 elliptical pipe. So if you put on your plans a Class 5 elliptical, that is not correct. They are it's Class 1 through Class 4. And in the fill height charts, I'm going to show you in a moment. They when you look at those, you've got vertical and horizontal, so they're different. The pipes are different. The reinforcing and stuff are different. So for elliptical pipe, there are 4 standard classes. Apologize, Jeff, you got distracted there, and I set you up for failure there. So we're going to get back into what we show on the plans and go through this quickly here. What do we show on the plans? Well, we show inside diameter, length, and slope. We show the RCP class. We mentioned there's 1 through 5, but locally you'll rarely see a Class 2, but every now and then, if it's a large diameter or irrigation project, you might want to spec out a Class 2. but mostly class 3 through 5 locally is what we do. And you'll want to put a trench detail on there so that the contractor knows how to install it and what type of bedding you're using. So then the question is, which class do I specify? Boy, which class do I specify? Well, there are 3 different ways that you can determine which class to specify. Number 1 is the Pipe Pack software. You can do your own indirect design and determine what it is, and we'll talk a little bit about that at the end, but not much. I'm going to give you a link on our Facebook. I'm going to put a link to a YouTube video that you can watch if you want more information about Pipe Pack, but I'll walk through it real quickly after this is over. Fill height charts is the most common way to do that, and you can download those at mountainstates.concretepipe.org. And the best way is just give me a call. Ask me. Let's talk about it. I'll pull up the fill height charts. We can talk about what class you should specify. We can talk about your loading, your fill requirements, and I can answer. And you never know, you might get a good joke or something out of me. You might get a good story. Speaking of which, Heather, got a question for you here. Why did the number 4 not ask the number 5 to prom? Do you know? Do you know why 4 didn't ask out number 5?
I have no idea.
Because it was 2 squared. That's the level of joke you're gonna get if you call me and ask me what class of pipe. You might get jokes like that. So I'm just saying, number 4 didn't ask out number 5 because it was 2 squared. You're welcome. Use that one today. You're welcome. Okay. If you go to our website, down on the bottom of the home screen, there's the fill height charts you can download. However, if you noticed, I provided 2 handouts for you on this presentation. So if you want copies of those fill height charts, those are available to download as handouts of this presentation. So there's a little handouts tab there on your control panel. Click those. Those are both available there in PDF. Feel free to download them, and then you've got access to them. This is what you'll see on these fill height charts. It's really easy, really easy to use. You're going to see a trench detail here. Now, all of these are for embankment installation. Now, the difference between a trench and an embankment is going to be more conservative on this. All right, your standard trench, you're going to have some friction forces on the sidewalls there that help a little bit with the loading, and it decreases the amount of point load that's on the top of your pipe. So an embankment is basically, when we install an embankment style, you put the pipe on the ground and then you build up around the pipe. So it doesn't have the benefit of that friction force of the sidewall of the trench. About 99% of the installation that I've seen in Utah is trench. And even when it is embankment, when we build it up, usually they'll build and do like a positive embankment trench where you build the embankment and then they trench and open it up and then install the pipe. And so it's a little bit different. It's not it's not the same as some of these other things that you'll see with just a standard embankment. So these are very conservative, but keep that in mind. This is the type of installation. The way that I say it is type 1 is your primo installation. This is like your typical federal, your FHWA, your DOTs, your airport, your railroad requirements. That's a type 1 installation. You've got high compaction, really quality material, and your bedding and your backfill is really good material there. Your type 4 is going to be your no compaction, your native materials. You're just throwing it back in the trench. So type 4 installation, you're going to save some money on the backfill and the material, but you're going to spend more money on a higher class. Type 1, you're going to spend more money on the backfill and bedding. You're going to spend less money on the class of pipe. So kind of balance those out a little bit there. Type 2 bedding is your kind of typically what you'd see in a municipal project. Sometimes I'll look at a type 2 and a type 3, see how close they are in classes, because sometimes if you spec out a type 2, if you're not out there inspecting and making sure it's being installed correctly, you may get a type 3 installation. So you got to be careful with that with your contractors. So this is what the fill height charts look like. They're color coded to make it easy for you so that you can see what they are. We're going to do a quick example, and I'll show it to you. I'll bring that up again. But here's the example. Let's set this up. For a 36-inch RCP, right, for a type 2 bedding, your flow line is 16 feet below the roadway surface. So we say for a 36-inch pipe, we know that that's a 3 foot from the flow line to the crown. And then we remember that 3 plus 1 inch, so your wall thickness is 4 inches, so 0.33 feet. So your cover on this pipe is going to be 12.67 feet. We're going to go ahead and use 13. We're going to round up on this to make sure that we have enough. We're going to round up on the cover so that we have enough load on there. We know we've got enough there. Okay, so for a type 2 bedding, We're going to go over here to our 36-inch pipe. Okay, we make sure we grab the right table for the type 2 bedding. We go over to 13 feet of fill, and then we go over here and we notice 1,003 pounds. It's yellow. It's between 1,000 and 1,350, so we know that's a class 3 pipe. All right, let's do another one here. 18-inch, 1 foot of cover. This is very common, type 3 bedding. We get a lot of calls about low cover. So we come over here to the type 3 bedding table. We go to an 18-inch pipe, a 1 foot cover. We go down, it's 1,384, so it's between 1,350 and 2,000. We class up to a class 4 pipe for a 1 foot of cover on an 18-inch pipe. So you notice some of those in the pink and the orange, it's a class 1 and class 2. For those, you would just still spec a class 3. But if we get really low cover situations, you're going to see some class 4s and class 5s in the smaller diameters. So keep that in mind. For a type 1 bedding, you can get these fill height charts. We can go all the way up to 42 feet is what we have standard in these tables. If you notice the purple, that's a special design. So we have, there we go. The class 5 goes up to 42 feet in type 1. Type 3 bedding, you can get up to about 30 feet, but anything above that, we can do a special design. Mike Blackham tells a story about a pipe that they did up in Montana that was 86 feet of cover. So they had to do a special design for that. Crazy. The last thing I'm going to talk briefly about is this pipe pack. This is a web-based software. If you want to get in and mess around with this, this is your direct design. You can get on there, just Google pipe pack, and it'll come right up with the American Concrete Pipe Association website. You log on there. This is the screen that you proceed to the application. There's some different analyses that you can do. We're going to focus on the 3-edge bearing test today. You create your project. The 3-edge bearing test, you can also do a cost analysis for pipe envelope, comparing different pipe materials. You can do a life cycle analysis comparing pipe materials, but we're going to do a 3-edge bearing analysis for our concrete pipe. Okay, so when you do that, we're going to use ASTM and US customary units. You can use metric, and CSA is the Canadian version of AASHTO. So if you're doing anything in Canada, you can use metric, but we use US customary here. I always say there's 2 different types of countries in this world. Those that use the metric system and those that have been to the moon. So just keep that in mind. Go USA. All right, so when you get in here, you fill in your pipe information. We're going to look at a circular reinforced B wall for 24-inch diameter. So you enter in all this information. You then click on the load tab. We're going to use the standard 120 pounds per cubic feet, which is what's in all those fill height charts. If someone's requiring a different one, like a 130 or a 125, you can type that in, and you can determine how much fill you're going to have and how much you want this table to look at, what type of bedding you want to do. You can choose just a type 2 bedding. You can choose 1 through 4, all these different bedding types. And then when you click and analyze on the results page, this is what comes up. It has a summary of all of your inputs, and then it gives you this table here. So you can go in and say, okay, for let's say the type 2 bedding, we did analysis on a type 2 bedding, a 13-foot cover for a type 2 bedding. If you notice there, this one where we did for a trench installation, remember that other one for the fill height charts was embankment. This one I did for trench. So you notice that for an embankment, it called it out as a class 3, but for an embankment, this one's a class 2. So it's kind of interesting how it changes a little bit there, what the loading is. So keep that in mind. Just kind of different, and things can change a little bit depending on the diameter and the type of installation and the embankment there. So the takeaways from this, obviously we talked the basics of RCP. We talked a little bit about manufacturing and testing, and then how you can design and what you should include in the specs. Hopefully this was helpful to you. We're going to do the questions now. And then this is my contact information that I put up on the screen. If you have any questions, feel free to email or call me. And there's our website. You can get on there and see all the cool stuff that we talked about today. So I'm going to pull up the questions pane today, and we're going to see what we've got here. So Justin asks if that is really a picture of Jeff. And as I say, yeah, that is definitely Jeff. Like I say, he's the closest embodiment to Ron Swanson I've ever met. And Justin said he didn't think that Jeff's mustache was that full. That is a award-winning mustache that we showed up there. So you're welcome, Jeff. And Jeff, this is a question for you. How much bacon do you eat per day on the program?
When I was when I was in ketosis, it was a minimum of a pound of bacon a day, working upwards towards 2 pounds of bacon a day.
1 to 2 pounds of bacon per day. See, that is the most Ron Swanson thing I've ever heard. Perfect. Bacon, getting on the program. I'm getting back onto it too, and I'll tell you what, I love bacon and eggs. That's my favorite. In the words of Ron Swanson, there never was or never will be a sadness that could not be cured by breakfast foods. So there you have it. Doug asks, if we view past webinars, will there be a way to obtain a PDH credit? That is a great question. This is the way that we're using this software, this GoToWebinar software. It will track who watches the webinar, so I can tell who has actually attended and watched. So yes, Doug, when you watch a past webinar, if you miss one and you watch it later on, it will track and tell me who watched it and who viewed it, so that we can get you your PDHs. So even if you miss one month, you can go back and view it later and still qualify for the PDHs. Great question, Doug. Thank you. Thank you. And Jeff, who has left, but I'll email him this question. What is the minimum cover needed to take highway loads? This is a question we get a lot. A lot of it depends on the different municipalities, the different states, the different DOTs. Some will allow you to go as low as 1 foot of cover. We recommend 1 foot minimum. Anything below that, we can still run in pipe pack. I've had questions. I know we ran one with Ogden City. The city engineer called and said, look, we're only going to have about 9 inches of cover. So we ran pipe pack for 6 inches of cover, 9 inches of cover, and 12 inches of cover, just to see what the difference would be in classes and see if we would need. And we found out that a class 5 pipe at their 18-inch diameter would be adequate for 9 inches of cover. So while we don't recommend going under that, because the problem you run into is when you look at the bells and spigots of these pipes, the bell sticks out of the ground a little bit, and you don't want that in your pavement section. So typically for a 6-inch pavement, a 6 inches of asphalt, if you have 12 inches of cover, you might be into the untreated base, but you want to keep it out of the asphalt. Now, can you pave directly on top of it? Can you? Sure. If we know that that's the situation, then we can design around that. But in addition to just the load of the highway loads on there, what about construction loads? That's one thing that a lot of people forget about, is that construction loading of, if you're only going to have 1 foot of cover, what's it look like as you're building the road around, as you're compacting the base on top of it, as you're compacting the asphalt. So you're going to want to check with each individual municipality, check with the DOT, check with what their requirements are, and maybe you need to look at going to an elliptical pipe or 2 barrels of, instead of if you can't make the 36-inch work, maybe 2 30 inches or 2 24 inches or something that you can make work, or an elliptical pipe. Those are some solutions.
A box culvert can be designed for 0 feet of fill over top, and so essentially you're just working with the top slab of that box culvert.
That's a great question. That's fantastic, because we've seen that where maybe you use a smaller box culvert with maybe 8 inches of an 8-inch wall, an 8-inch thick wall. But if you can make it a 2 foot tall instead of 3 feet, that could be a big difference there. The difference between whether we let it work, and you can drive right on top of it, as Heather mentioned. Great suggestion. You can use that as your driving surface. So those are some very good options there that you can look at. But that's a great question as far as meeting the highway loads. Those fill height charts were for your HL93 loads, and you can choose HL93, HS20, whatever load you need to do in pipe pack, you can determine. So as far as meeting those highway loads, you can go 1 foot, or we've seen it go a little bit less if necessary. We don't recommend that, but it is possible. If we know what the situation is, we can make sure that we're using the right class, or we can do a direct design for it. But that's a fantastic question, and probably the question we get most often. Lastly, we did have a comment that maybe this is the fun fact that I left out of myself. It says, Jason, I thought you left off your resume that you played Pumbaa on the Broadway hit Lion King. Yes, I have been mistaken many times as being Pumbaa from the Lion King because of my stunning good looks and my ability to hit those high notes like Pumbaa. So yeah, no, I did not play that. I didn't leave it off my resume because it wasn't me, Justin. It was someone else. But I know I do look like a warthog. But I appreciate that. Those are all the questions that I received. But thank you all so much. If you have any specific questions that we didn't get to, or that you want to ask, feel free to email us. you know, I mentioned, I put Heather and Mike and Jeff's emails on there at the beginning of this presentation, but we should have this uploaded within the next day or two to our past webinars, so that if you want to get on and view it, or if you want to invite someone from your office to view it, you're more than welcome to do that. So thank you all for sticking around to the end. We had a lot to get through and a lot to cover for this first webinar for the Academy. So next time we're not going to spend the first 15 minutes explaining all the stuff about the those the other you know, all the stuff with the Academy and the association, but we'll jump right into sustainability next month. So keep an eye out for that one. We'll be sending out invites to that. Yes, we will be emailing out these PDH certificates. We will send those out within the next week to everybody that attended. So keep an eye out for those. I will get those. I will be sending those in a PDH format. You just print them out, write your name on them, and then you can use those if you get audited. So if you have any other specific questions, feel free to email me. We look forward to seeing you at future webinars. And thanks again, Heather and Jeff. Is there anything that you want to add before we go?
No, I think you did a wonderful job, and you know, I look forward to this monthly webinar. I think it's a good forum to build some knowledge in the industry.
Fantastic, and we just really appreciate everybody that's in attendance. Thank
Absolutely.
you for.
Yep, thank you all so much. We appreciate it. Hopefully we'll catch you next month. Tell all your friends. Let's try to get those numbers up so that we can have more people attend and get more prizes out to everybody. So the more people that attend, the more that Heather and Jeff have to spend on prizes. So make sure you get all of your people in your office and let them know that they can view it at any time. So let's get those out. Appreciate everybody. Thanks again.
Closing comment too is that if you guys have a project, send it our way. You want to nominate the Mountain States Project Achievement Award, please send it our way. We'll work with you to get that project narrative written out and get it all formatted, ready to go on the website and be one of the recognized projects of the year.
Yes, thank you. Great reminder, Heather. Thank you so much. Yes, email those to us, those project highlights, and we'll have upcoming projects. Hopefully we can highlight yours on one of those upcoming ones, and maybe you'll win the Project Achievement Award at the end of the year. So thanks again, everybody. Thank you, Heather. Thank you, Jeff. Appreciate all that you do for the association, and appreciate everybody that attended and all that you all do for the association. Let me know if you have any questions. We'd love to help you out.
Thanks, Jason.
Thanks everyone. Bye.